Hello everyone, I'm RJ, FAE of Nuvoton Technology. Today I will teach you how to use the SEGGER emWin AppWizard tool to create a graphical human-machine interface for an electric bicycle. We will use the M467 evaluation board to demonstrate. And before this video, if you would like to familiarize yourself with the basic operations of the SEGGER emWin AppWizard interface, I recommend watching the quick start video in the information section or information card. So in this video, we will go through 4 parts to explain how to use the AppWizard tool to complete an app flow. First, in step 1, we need to prepare the necessary hardware and software. Then in step 2, we can use the AppWizard tool to design the GUI. After completing the design in step 3, we can generate the code directly and import it into the board support package. So in this way, we can use the existing sample code structure without additional coding. And of course, you can also add custom code to enhance functionality. And finally, we will demonstrate how to run the design onto the device to complete the entire app. So from a block diagram perspective, in this example, we will use the external bus interface and accuracy interface to control the screen and touch respectively. And additionally, we will store image resources in the SPIM flash and access them using the so-called SPIM interface. So next, let's see how to obtain the necessary software resources. So here we will need 2 software items. The first one is the emWin package provided by Nuvoton for the M467 series. And the second one is the BSP package for the M467 series. So we will guide you step by step on how to download the software resources. First, we go to the Nuvoton official website, navigate to the product section, and find Microcontroller, then ARM Cortex-M4 MCU. So locate the M467 series and click to enter. So after entering the M467 series, click on Resources, choose Software and select the HMI library. So here you will find the download link for the emWin software package for the M460 series. So just clicking on it and it will prompt a login page. So if you haven't registered as a member of Nuvoton, please register first. Once registered, you can log in and the emWin package will be automatically downloaded. And let's see how to download the BSP package. So go back to the resources page. Under software, find the board support package and click on it. You will see the M460 series BSP and download the latest version, and it will be automatically downloaded. So after downloading, just unzip both of these items. Once the extraction is complete, we access the M467 emWin package and unzip the M460 emWin non-OS. After the extraction, we open both the M460 emWin non-OS and the M460 BSP package. So first, we copy the emWin folder from the M460 emWin non-OS and pass it into the third-party folder in the BSP. And next, go back to the previous level. Then we copy the remaining example code from the emWin demo and pass it into the sample code folder in the BSP. It's just under New Maker M467 HJ. So this completes the integration of the emWin package and the M467 BSP package. After completing the steps to port the emWin package to the BSP package, we proceed to install the AppWizard tool. So first, go back to the M460 BSP folder and navigate to the emWin folder in the third-party directory. You will find the tool folder inside. Once inside, you will see the installation file for AppWizard. So just double-click to start the installation. And here, if you have previously installed the AppWizard tool, please uninstall the old version completely before installing the new version. So once you have completed the installation of the AppWizard tool, we can proceed to step 2, which is designing the GUI using AppWizard. Before we start using the AppWizard tool, let's take a look at the elements we will need on the screen for the e-bike project. So firstly, we will definitely need a speed meter and a numerical display to show the speed. And additionally, we will have elements to indicate the battery level, icons for indicating the direction indicators, and warning messages for potential dangers. And furthermore, we might want to display the tire pressure for the electric bicycle. So we will have a tire pressure display page showing the pressure for the front and rear wheels. And in addition, we may want to implement a language switch where the user can switch between Chinese and English or etc. So now let's see how to use the AppWizard tool to design and complete an electric bicycle project. So let's directly open the downloaded AppWizard tool. So after opening it, select the Create New Project. You will be prompted to choose the project location and set the project name. Once selected, choose the resolution and color format supported by the screen. And next, check the Enable Multi-Buffering option and click OK. So after the project is open, we can start designing the screens. So in the AppWizard rules, each app screen is composed of screens. So for this e-bike example, we need a total of 2 screens. So click on the screen object in the top left corner of the object column to create 2 screens directly. And after creation, you can see the corresponding ID names in the tree. Here you can modify the ID names for easier identification during editing. And for the first screen is related to speed display, so we name it speed. And for the second screen related to tire pressure, so we name it tire. And next, let's edit the layout of the first screen, so the speed display. So the first, we want a solid background color for the speed display, so we select the box object. So after clicking on it, you will see it appear in the tree on the left side. So you can also make some attribute settings for the box object, such as color. And here we need it to be completely black. So you can drag the color picker to set it as black and click OK to see the changes. So since our background is a solid black color, we would like to import a simple separator line image to serve as a display area for some icons on the dashboard. So let's see how to embed it and edit an image. To embed it an image, just click on the image object. After selecting the image object, you can see the bitmap option in the Properties panel on the right side. So just click on bitmap here. Then you can import your own design image by accessing the files. Here, just use the Shift key to select all the required images for the project at once. And after importing, you will see the images appear in the image library on the left side. So next, click on the separator line image we want for this case and click the select. So it will appear in the bitmap file. The current size may not be suitable, so you can right-click on the image in the layout and choose Set Size to Content. It will automatically adjust the size to fit and display it in the layout. Then you can use dragging and alignment to position it on the grid where you want it. And another important note when setting the bitmap for the image is that when we click on the bitmap to access the image library, there are several fields. So the first 2 fields represent the width and height of the image. Then there is an applied that indicates whether the image is used in the project, and it displays the number of times it used. And next is the format, which refers to the color format the image should be displayed in. So in this case, we need it to match the screen's RGB 565 format. So after selecting the format, just click Apply, then you can click into the bitmap again to check if it has been successfully set. If it is successfully set, it will be displayed in the setting file. And this completes the embedding of an image. And next, let's add an object that can be used to display the speed. Here we can use a rotary object to represent it. So after clicking on it, you will see the default style of the rotary. So you can rename it in the ID file for better recognition in the future. So now let's understand the properties of the rotary object. We will use the same slide to provide supplementary explanation for the rotary properties. So for the rotary object, its bitmap is divided into 2 parts, the background and the pointer marker. Other settings include initial values and value ranges for the rotation knob, and additionally, special attention needs to be paid to the angle-related properties, such as the starting angle, the radius of the circle, and the alignment of the pointer. So you can refer to the default angle shown on the left side of the slide. The starting angle is on the right side, representing 0 degrees. It will rotate counterclockwise for 360 degrees. And the image on the right side is the background for the speed display that we will import later. So therefore, our speed display will start from the defined position of 210 degrees as the 0 speed value and rotate clockwise for 240 degrees to the maximum speed value we set, which is 80. So as a result, we will have some settings as shown in the table on the right side of the slide. So next, let's go through the actual setting of this rotary object. First, we need to import the background image we want to use. So just select Bitmap and choose the image we have prepared. And after clicking it, choose the color format as before. So just click OK and then click Apply. Next, we need to select the marker image for the rotary. After the selection, just right-click and choose Set Size to Content. Then, as mentioned earlier, we can further customize its properties. And first is the initial value. And here, we will start it from 0. So next is about the angle range. We will set it from 0 to a total of 240 degrees with the unit being 10 times of the angle. Then we have the range of speed values, which will go from 0 to 80. And next property is the offset, which sets the starting angle position. Here we start rotating from the earlier mentioned 210 degree position. Therefore, we set it as 2100. So with these settings, we can click on the Play Mode button in the top right corner. This allows us to have a quick preview of the current design. We can see that the rotary rotates correctly, but the pointer is not aligned. So to close the Play Mode, just click on Close in the window. Next, let's see how to align the pointer. So first, we can set the rotation radius of the pointer to 0. And after setting it to 0, we can align the pointer using fine adjustment in the XY coordinates. When the pointer is roughly aligned with the center of the speed circle, we can use the radius setting to align the pointer to the desired rotation position. So once the alignment is done, you can click on Play Mode again to see the current design result. So this completes the design of a speed meter screen. And in addition to the graphical representation of speed, we also want to add a numerical display to show the speed synchronously. So to add a number, we can click on the text object. So after clicking on it, we can name the text ID for easy recognition later. So just move the text object to the desired position. Now let's take a look at the properties of the text object. So the special properties of the text object are set text in set decimal or hexadecimal mode. So these properties determine whether the text is displayed as words or as numbers. So if it is displayed as a number, we can set the range of numbers to be displayed. If we want to display text such as unit names or battery names in the overall design of this dashboard, we will use the setText function to set it as a text. So let's go back to the AppWizard interface and go through the actual operation. First, we want to add a number, so we set it to decimal mode by opening the decimal mode. Then we can set the color and choose the font for the text. And next, set the range for the numerical display. Since our speed ranges from 0 to 80, so we will set it accordingly. So this completes the configuration of the text object as a numerical display. And next, we want to set the text to display words. So similarly, we add a text object and place it where we want it. So set the color and choose Set Text. So in this case, we will practice adding text for the first time. So when no text has been added yet, you will need to select New Language. So let's start with English. Then click on Add Text and the first text will appear. Just double click on it and to edit the content. Then click Select. And next, set the font for the text. This completes the effect of displaying text using the text object. So we can use the text object in the same way to add text for battery and its unique display, as well as the numerical display for the battery level. And the next screen design is about the indicator lights that are commonly seen on any vehicle, such as turn signals or various warning lights. So in terms of layout and functionality, we will use the button object to represent their on and off states. So we can use the values 0 and 1 to determine whether the function should be on or off. And regarding the properties of buttons, it's important to note that buttons have 3 states, which are pressed, release, and disable. And additionally, you can customize the button's color and add other functionalities. So now let's go back to AppWizard and add the button object. So just click on the button and you will see its default style. So just rename the button's ID for easy identification. And next, let's look at its properties. So clear the text color setting, click on the bitmap setting and choose the images for the buttons on press and press states, and adjust the position of the image on the screen. And we can use the same approach to add indicators for the turn signals and headlights. And next, we want to add a feature that displays the battery level. We can use either the program bar or gauge object to present the battery level in different visual styles. So in AppWizard, let's use the program bar object to display the battery level. So select program bar from the objects on the left side and adjust its size and position on the screen. Then look at the properties on the right side. Set the initial value and range. Clear the bitmap setting and use the Set Color option to customize the display color. And other properties such as the arc, angle, and border can be adjusted according to your needs. So with this, we have completed the design for displaying the battery level using a program bar object. So if you want to use the gauge object, just pay attention to its properties as they are related to angles. So you can use your experience in setting up the rotary object to configure the gauge object for displaying the battery level. So far, we have completed the design for the first screen, which is the speed display. Next, we will proceed with the design for the second screen, which is the tire pressure display. So we will add a background image for the tire pressure display. Just select the image object and import the desired image. And next, follow the steps to add text to the screen. Add some text to display relevant information. Then add the tire pressure value using the text object. And to enhance the design, add the bicycle icon in the center of the screen. Just select the image object and import the bicycle image of your choice. With this, we have completed the basic layout and design of the tire pressure display. And to allow the second screen, which is tire pressure screen, to navigate back to the first screen, which is speed display screen, we will add a button that functions as a back button. So now let's discuss the implementation of language switching. So click on the text object in the bottom left corner and add a new language. Let's take Chinese as an example. Enter the Chinese translation for each text item. And click Apply when done. And in addition, we need to make sure to select a font that supports Chinese characters for each text item. So use the Create New option in the font window to import a font that supports Chinese characters, and customize the size and type, and edit the character range as desired. We need to select Project Text only to apply the corresponding font type. And next, let's import two buttons for language switching. So we expect that pressing the first button will display the screen in English, while pressing the second button will display it in Chinese. So now let's see how we can achieve the expected interaction and add some animation effects to these screens. So first, let's complete the transition between the two screens. Add a setting button that, when pressed, will navigate to the tire pressure screen. In the interaction file, set the button's functionality for screen transition. So select the emitter with the specified ID and choose Click for the signal and set the job as Show Screen. And preview the functionality to ensure that it transits to the second screen when the button is pressed. So similarly, set up the second screen to transition back to the first screen. And now let's implement the language switching functionality. So when the language switch button is pressed, use the Set Language function to set the language index to 1 for displaying Chinese and 0 for displaying English. So let's test this in play mode. So while we pressing the Chinese button to display the interface in Chinese and press the English button to display it in English. So in this way, the button's actions can be used to switch between different languages. Back to the speed display screen, we will now create an animation for the speed display and its interaction. So click on the animation button in the bottom left corner to open the animation editing window and select animation and then edit. So you can modify the ID of the animation for better identification and enable the auto start option, and set the total duration of the animation in milliseconds. And next, set the object that will be animated. So choose the object value option and select the object on the screen you want to animate, and set the initial and final values for the animations. So here we want it to go from 0 to 80, so select fixed value and add the appropriate values. So to create another animation from 80 to 0, just simply click on the Add Item button and set the values accordingly, and adjust the time proportion on the left side to determine when each animation should occur. So once you are done, just click Apply and OK to finalize the animation setting. And next, in the interaction section, declare the animation initialization. So select the ID of the screen where the animation will be displayed in the emitter file. So choose Init dialog and select Animation Create in the job. And in the animation window that appears, choose the ID of the animation you created and click OK. So this completes the animation setup and enable it to be displayed on the screen. So we can use play mode to preview the animation you just designed. You will see the number animating from 0 to 80 and then back to 0 as per your animation setting. And now let's synchronize the rotary speed with the changing number in the middle. So in the interaction section, select emitter text speed and choose value change for the signal and set the job as set value. So select the rotary speed object as the receiver and click OK. So when you test it in play mode, you will see the rotary speed changes along with the number. So similarly, set the battery level number to be linked with the program bar that displays the battery level. So in the interaction section, just select the text for the battery level and choose value change for the signal and set the job as set value for the program bar. So in this way, when the battery level number changes, it will also affect the display of the battery level bar. And now, let's explain how to receive values from the MCU in AppWizard. So we need to configure the variables in the bottom left corner and open the variable window and click on Add Variable. So let's name the variables for better identification. Once you have set the variable names, just click Apply and then OK. Next, we need to configure the interaction between the variables and the objects. So set it up so that when the variable value changes, it will be assigned to the battery number display. So once this is done, you only need to add a specific API line in the code to send the MCU calculated value to the screen for display. So far, we have completed all the screen layouts and configurations, including various animation, page transitions, and language switching. And next, we would like to run this app on the board, so just click on the File menu in the top left corner and select Export. Then choose Project and click on Open Company folder to navigate to the project directory. So now replace the AppWizard output files in the sample code folder of the Nuvoton M467 HMI in BSP. And go to the application folder in the BSP sample code and replace the original files with the newly generated ones. And open the Kyle project. First, go to Manage Project Items and delete the original files under the application group. Then add the newly generated AppWizard project and import all the files into the project items. So once all the files are added, you will see the results in the project tree. And now let's take a look at the structure of the entire code. The program will start from main.c, where the system clock and communication interfaces such as the screen and other interfaces are initialized. Then the program enters the main text2 function in appw_main_text2.c. And here, the initialization of the AppWizard and the execution of join and AppWizard texts in the while loop can be observed. The AppWizard texts are defined in each .c file named after the screens, so you will also find the content of the interactions we set in the file named ..slot.c. And going back to the while loop in main task, we can add functions like appw_set variable data and input the variable ID for the battery level as well as the value received from the MCU. So in this way, the battery level number will display the value sent from the MCU. Since human-machine interface projects often require a large amount of space to store image resources, we can use an external SPI flash to expand the storage capacity. So the Nuvoton M467 series supports SPI master mode for the SPIM interface. When the direct memory mapping mode is enabled, the external SPI flash can be treated as a ROM module. So by storing large resources like images in the SPI flash, we can quickly access the resources and improve overall execution performance. So now let's see how to add SPIM functionality to the program. So let's go back to main.c file and first enable the system clock source for SPIM and define the multifunction pins for SPIM. And open Manage Project Items and add the SPIM.c library to the project's libraries. So we need to initialize the SPIM functionality. So for reference on SPIM related functions, you can refer to the sample code under BSP. And in this case, we will use the direct memory mapping mode and choose between the dual or quad mode based on our needs. And open the linker scatter file by going to Options and Linker and enabling Edit option. So in the linker scatter file, we need to specify the execution addresses for AP-ROM and SPI flash. And connect the board using a USB cable and set the programming pin configuration. Just click on Options, then Utility, and select User SPIM. And set the pin configuration in the multifunction pin setting to match the pin configuration we define. Once the programming pin configuration is set, we can rebuild the project by clicking on Rebuild and then download the program to the board by clicking on Download. After successful programming, we can see the program screens as we designed in the AppWizard tool. The speed screen shows the automatic speed display effect, and then we can switch between different screens using the buttons. And the language switching feature is also functional. We can switch different language here. And when we return to the speed screen, we can see the customized code we added in the CAL project. So the battery level input is displayed on the screen. That's all about using the AppWizard tool to create a simple electric bicycle project. Thank you for watching, and welcome to subscribe to our channel. So if you want to get more information, please contact us.